Good afternoon, everyone. A very warm welcome to the Phase 2 webinar series of Solar Decathlon India. I am Amanda Thaunauzam, and I will be your session moderator for today's webinar. So before we start, I would like to thank the Department of Science and Technology and Ministry of New and Renewable Energy for their support. I would also like to acknowledge the support of our sponsors and affiliates of Solar Decathlon India. So today for this webinar, I have with me Anmol Mathur and Shubham Solanki, who would be demonstrating the features of Climate Studio that can be used for effective net zero energy building design. Through the software interface, they will discuss the application of various energy conservation measures and also understanding the results to make effective design decisions. So Anmol and Shubham have completed their master's in building energy performance from CEPT University and were part of CEPT Solar Decathlon 2019 team. Anmol has gained experience in research and simulations on the urban scale while working at CARBS, while Shubham has rich field experience in the domain of HVAC systems, controls, and commissioning while working on the Global Cooling Price project with CARBS. They run their own environmental and sustainable design consultancy, Co-Lead LLP, based in New Delhi and works with architects like Vastu Shilpa Consultants and Seagull Studio, building owners like Aero Manufacturers, and Santosh University on integrated sustainable design, energy efficient MEP design, and certification projects. So we welcome you, Anmol and Shubham. And to all the participants, please feel free to send your questions in the Q&A window anytime during the session. We will take them up one by one towards the end of the session. So with that, over to you, Anmol and Shubham.
So thank you so much, Amanda and Prasad sir, and the entire team of Solar Decathlon India for having us today on this webinar. And as Amanda introduced, we will be focusing this webinar towards the energy modeling software that has been provided to the participants, that is Climate Studio. Our agenda for today's webinar would primarily consist on 4 aspects of the software, and not only the software but also in general about energy modeling and how inputs and outputs can be related, what the modeler should be wary of, and how they should address the errors and address the challenges that are faced while setting up the model. So you guys have already been given a few webinars by the Solema team on how to use Climate Studio. They also have an entire series of video focusing on different aspects of the software. So our agenda is not primarily as a software tutorial, but we will try to understand what goes behind an energy model, what the inputs look like, how a model should be set up, because I think that these are the most important aspects before anyone starts towards energy modeling. Climate Studio is fairly developed in terms of its interface, and it has a lot of pre-designed workflows so people can readily access that. But the 4 things essentially that we will focus on is a model setup, that how do you actually start modeling the geometry, what are the aspects towards that. Essentially it is based in Rhino and Grasshopper, so what are the tips and tricks that will help you model those geometries more quickly. Shubham will then focus on the templates and the model inputs, which is actually the most important part of any energy model. What goes in will actually come out, because it's essentially an equation that tries to solve different parts of your geometry. The next part, we will try to understand how do you actually run an energy model, what the results look like, and how do you start understanding and making sense from these results. We will also demonstrate a quick workflow of running natural ventilation simulations, but we'll not get into a lot of details on it right now in the interest of time. So I think I'll start projecting my screen and let's begin. So I hope my screen is visible.
Yes, Anmol.
Right. So essentially, you all might have already installed and started working on Climate Studio. Climate Studio is a plugin essentially developed for Rhino and Grasshopper. Grasshopper is a visual scripting software which works in Rhino, and Rhino is a CAD software. So most of the architectural students will be aware of, and they might have also used Rhino for their architectural modeling, but today we will try to understand it from the perspective of energy simulations. So today we will be modeling our uh, the design that we had presented during Solar Decathlon 2019, which was a mixed-use multi-family housing project, and we'll be modeling a one single uh, floor of a typical block that we had developed, and in that we'll be able to explain different aspects of the software. So when you install Climate Studio, you will find this kind of a tab on your screen where you will be able to find all the various functions of Climate Studio. You can also drag it in your panel bar where you will be able to see different modes of the software. Essentially, the software has been developed in two parts. It can be set it up in Rhino as well as in Grasshopper, but when the modeling becomes more complicated, we have to switch towards Grasshopper and start the visual scripting in that. So today we will try to break that hesitation which many people have, that how do you start working in Grasshopper, which I think that most of you would be facing a challenge in. So let us start first by understanding the model geometry. For any uh, for any 3D modeling software, it is important that we start working in layers, because essentially it is important to have a good control over what you are modeling. It also helps in the later stages when your design becomes more and more complicated and things become more and more jumbled up. So we begin by modeling all our different rooms that will essentially convert into thermal zones in different layers. So as you can see in this plan, the plan is fairly simple. It consists of 1 and 2 BHK dwelling units with a core in the center. And we will be modeling all the rooms as individual thermal zones, because you might have also read about that a thermal zone is something that has similar conditions inside, and it assumes to be having a fairly mixed kind of an environment. The air is well mixed and the temperatures are fairly constant in a single zone. So
Anmol,
it is
sorry to
essentially,
interrupt, but I think your screen is frozen. Is it only on my side, or Shubham, is it on your side as well? Looks like your screen is frozen.
what are you seeing on my screen right now?
So
I
I'm
don't.
seeing your Rhino as well as Grasshopper screen right now.
Okay, so I think then that's a problem. Just give me a second. I'll just
Sure, yeah.
reshare. Uh, is
Okay.
it better now?
Yes, yeah, it looks active now. Yeah.
Sorry for the glitch. So
No
as I
problem.
was mentioning that we have to model each and every room as a thermal zone, because each and every room will have different exposures, first of all, to the outdoors, and also it will have different occupancy and internal loads. To begin with, we will start looking at how do you actually set up your model. Uh, Modeling for energy simulations requires you to create closed box volumes which will represent your thermal zones, and the essential part is that all the geometry has to be planar and it has to be in a closed box. I know that many designs will have a curved or a fairly complicated geometry, but then you will have to work out ways to create it into or break it into planes so that your energy model can reach the surfaces appropriately. Essentially, when we convert any model into an energy model, it will start understanding different surfaces like walls, floors, roofs, windows, shading, and essentially it will assign different properties, and from that it will start calculating thermal balance equations. So in this model, I have created from the box in Rhino, we have created different zones, as you can see, and all the different zones have been developed in different layers. So I have a layer for my bedrooms, place. It is important that all your lines are very clean and clear and they do not intersect, because all of this will start creating problems when you enter into the simulation software. So now let us look at how do we start from this geometry in Rhino, and we start into Grasshopper and setting up our model. So for those who are fairly aware about Grasshopper, it is a visual scripting tool. It is used to perform various activities, and essentially it consists of these tabs and these wires. What these tabs are, they are basically functions which have a certain input and a certain output, and these wires are basically connecting different inputs to different outputs. To begin with our model, we have imported our Rhino geometry into Grasshopper using a brep command, which is a boundary representation, and for different zones we have taken different breps, because essentially in the model we will want to assign different properties to different zones. So that is why we have created all these zones separately. I'll just switch off all the layers in Rhino and then we can start visualizing the geometry in Grasshopper itself. So as you can see, these are the bedrooms, the living rooms, kitchens. They have all been assigned in different breps. The next part is that you need to make sure that your model is well intersected and all the surfaces, the internal partitions, are coplanar, they are adjoining, and they are not intersecting with each other. So the command that Climate Studio offers in Grasshopper, it is called intersector. Another tip that I'll just quickly want to share: if you have these kinds of scripts available from Climate Studio and you are not able to figure out which component comes from where in the ribbon, you can just press Ctrl Alt and click on the icon, so it will direct you from where this particular command is coming from. What the intersect zone command essentially do is that it will try to solve the adjacencies between different thermal zones, because when we are modeling thermal zones, all the boundary have to be adjacent to each other, and essentially there will be heat flow from one boundary to another boundary through a zone to another zone. So this is a very important aspect. Before you start modeling, you have to make sure that your boundaries are correctly in plane and they are coplanar. When you perform this function, you will again get an output as zones. Climate Studio automatically detects the vertical faces as facades, and they give it as an output for windows. Although we'll not be using this output because we have already made our windows. Again, then we have used this command to retract all the zones separately, because we had inputted them as separate zones, but the output had come from a single zone. So the data structure, in order to maintain that, we have used this command explode tree, and we have again extracted the different zones. The difference between this geometry and the other geometry is that all the intersections have been clearly identified. So let's just zoom in here and understand that. If you can see that there's a line that has developed and the surface has been split into two, because the bedroom was sharing its boundary wall with half portion of the living room and half portion of the toilet. This was not the case in the initial geometry that I had modeled. So Climate Studio very effectively does this job for us, and it tries to clean the adjacencies as much as possible. The next step after that is to start assigning your zones properties. This is a function that I had to introduce because there were some issues in the geometry, so they were having a number of holes in them. So this command cap will essentially fill the geometry again, and it will make it a completely volumetric zone. So again, I have now recovered the intersected masses for all my zones, and now I am ready to start inputting them into zones. Before we proceed to that, we need to understand one more thing, that is the boundary conditions. So when we are modeling any geometry, there will be some conditions on the boundary of our model which will represent different heat balance equations. If you look into the Climate Studio tab, which says set boundary conditions, which looks like something like this. This is a command which says set boundary conditions. There are three kinds of boundary conditions: adiabatic, ground, and ground FC. Adiabatic essentially means that from this surface there will be no heat transfer. So if you are trying to model a building that is in between of a tower, it's like on the middle floor of a tower, so its exposure to the top and to the bottom of the floor will be the same. So essentially, to simplify things, we keep those surfaces as adiabatic, because there will not be a heat transfer from the top floor and the bottom floor. But then when we are modeling a geometry which is kept on the ground floor, the exposure to the ground will be very different. So therefore, we have a ground boundary condition which will try to calculate the heat transfer between your floor and the ground. Similarly, if you are on the top floor, then your roof should be exposed and your ground should be, your floor should be adiabatic because it's on the top floor. Ground FC is another a way of calculating grounds, which includes a F factor and a C factor. They are again some thermal equations, and if you want to read more about them, you can uh, log into Unmet Hours or Big Ladder software. It gives a very detailed information about different simulation inputs for Energy Plus. So for those who are interested to understand more, they can go back and refer to this. Now coming back to our zones, as I was mentioning that we have to create different conditions for the boundary. I am essentially modeling a ground floor only. So I am interested in having a ceiling which is adiabatic and a floor that is exposed to the ground. From this geometry itself, I have extracted these two surfaces, which I will now use in my model to assign different properties. Now coming to the windows, this is something that again you can create in Grasshopper itself. If you are trying to model window to wall ratios and you don't have a very specific geometry for windows, you can use you can extract the surfaces of your zones itself, and you can use a scale command to actually develop a window to wall ratio as per your requirement. So here I have extracted the different surfaces on different orientations, because I will want to have different WWRs on different orientations. So I have for each zone, I have the north and the south surfaces extracted separately. This is helpful because while doing parametric studies, we might want to explore different glazing percentage. We also want to explore different materials on different orientations. So these kinds of this is an effort that you have to make extra, but it will help you in the later stages of the model. The next thing that is even more important that I want to highlight is an internal air partition. What it essentially means is that there are zones in my model that actually don't have a partition in reality. This is a living room and the kitchen. It's a continuous single zone and there is no partition in between. But for thermal modeling, I need to assign and a boundary conditions to these partitions so that the heat transfer can be calculated from this zone and this zone between through this boundary. So essentially, we will have to extract these surfaces separately and assign them different properties. If they are opaque or if they are having some material, then you'll have to assign them the material, or else you will have to assign them as an air wall, or even a window can also be, you can also assign it as a window which is not glazed. This is very helpful when you are doing mixed mode and natural ventilation analysis, because you need to calculate your natural ventilation flows from the windows through the different zones. So the boundary conditions have to be modeled accurately, and that is why this effort has to be made before running the simulation model. So now if we are fairly well versed with the model, we have extracted all the geometry as required into Grasshopper, we can start assigning them different properties and we can start assigning them zones. The first thing is to assign zones to different boxes or different rooms, and for that we will use Climate Studio's command, which comes from the zone tab, thermal zones. In these thermal zones, you will essentially have to assign the geometry, assign a name to the zones, and then we will start with the zone settings. So now I'll request Shubham to go into more detail about these zone settings and make you understand what these settings are. And essentially these are the inputs for every model, and as far the geometry was concerned, this is equally more important for any energy simulation model. So over to you, Shubham.
Yeah, I will be sharing my screen. Yeah, hi everyone. Is my screen visible?
Yes, Shubham.
Yeah. So as Anmol told you that once the zone are set up, we have to give the commands to the zone. So here basically how we will start, we will first start scheduling the model. So basically after the zones are complete, zones are done, this is the second most important thing, which actually lead you to very close to the real life modeling, and that's where the scheduling is very much important. So scheduling is for basically loads, the internal loads of a building, then for the HVAC system, for ventilation. So whichever activity is happening in the model, all those things have the schedules, and we have to define the schedule and the property to those spaces. So basically, if we start with the loads here are of three types, which are the occupant load, the equipment, and the lighting. And since I told you about that, every load has the schedule. So if we so for that schedule, we first have to means there is this occupancy schedule. We will open this. We will observe that in all these schedules there are predefined schedule which this library already have, and in this library basically the default library we can't modify in the default library, and we can see that all these libraries have a log system which indicate that you can't edit in this. So to edit any occupancy schedule, you have to make one, you have to create a duplicate of this. If we give this name residential underscore SDI and something like this, then in the end of this whole list, you will see that there is one the schedule, and now you can edit the schedule. And once this schedule is being added as per the required occupancy of the particular system, so all the buildings will have the different occupancy schedule. You can refer the different sources for those. And once the schedule is being finalized, so if you open this, you will again have this one more tab where you have to edit the schedule again, where basically the whole input is being put. So here you again have to make one more duplicate of any tabs which you want to. So is this oh. In this we can edit anything whatever we want to. And so basically all these schedules have the number from 0 to 1. The 1 is the 100% occupancy or 100% usage of that particular system, and 0 means that it's completely turn off. So depending on that, you can put it as per the source which you are referring. And once that is done, just select this occupancy schedule, and then you can use that schedule. So here basically I'm not changing anything, and I'm just keeping it as it is, which was the original occupancy schedule, which is from the default library itself. So other than this load schedules, we have the schedule for the for the equipment, for the lighting, even for the HVAC, which is very much important, as we all know that it have the maximum usage. Same for the ventilation and the different other usages of the buildings. Other than this, other than this whole tab, the next part is basically the construction. So construction here again defines about the characteristic of the envelope, and those envelope characteristic also have the same pattern, the same way you can edit, and same way you can make a duplicate of that particular geometry. And once that geometry is done, so here also it's the same path, just make a duplicate, then define the name something, then you can edit. In the end you will find the your defined name, and then you can edit, and then you can use that whole particular geometry for that your for the envelope for that characteristic. So and this you have to basically follow for all the zones, all the geometries, all the spaces which you have done. This thing takes time at the first go, but once this thing is defined, you are very much close to your geometry. And and if and this is equally important as as you the way you have created the geometry, you again have to create this whole thing. So now over to Anmol for our next step.
Right. So just one thing more I would like to point out in the settings was the HVAC tab, where you will be able to give the details of your HVAC systems. So I'll try to open it up. It's fairly slow in my laptop, so please bear with me. So as Shubham had explained you the all the other tabs, which essentially assigns the schedule, the programs, the loads. This is the tab which I think most of you would be interested to understand about, which is the HVAC systems. So Climate Studio right now does not offer the capability to model different kinds of systems like VRF or water cooled chillers. What it essentially does is an ideal air load modeling, where you will be able to have a constant volume or DX system, which is then defined by basic parameters, by basic settings. So you can assign settings like the COP, the set points. You can also have a variable set point schedule, which means that if you are also working on the adaptive model for thermal comfort and you have different set points for different months, you can try using that as an energy conservation measure in this tab. The COP essentially is the coefficient of performance of any HVAC system. It will have different COPs for heating and cooling. So if you have certain products or certain models in place that you have figured out you will be using in your building, you can actually provide the COP of those uh, systems in your simulation model and understand how much energy you have saved. So if you go by a standard split AC, the COP would be around 1.2. And if you switch to a higher efficient chiller, it might even go up to 5 or 5.6. So you can check these specifications in the model. And just for the sake of brevity, you can avoid other parameters. You can just take assumptions on the COP and move ahead to understand how much energy your system is saving. The next part of that is mechanical ventilation. So essentially all these systems are modeled in a way that they also provide you fresh air and mechanical ventilation. Uh, Fresh air requirements can be modeled from ASHRAE standards or any other standard that you are referring. NBC will also give some requirements. But these are only for those kinds of systems which have a fresh air output. If you are using PTAC or a split AC, you will definitely not have a mechanical ventilation in your system. So therefore, you will have to introduce natural ventilation or some other system on top of your split AC in order to take advantage of this mechanical ventilation. So if in your simulation results you are seeing very high EUI values despite using a very low tonnage split AC, that means that something is going wrong. You might have left the mechanical ventilation on, and you need to go back and check these settings. Another thing that you can add in this tab is the energy recovery and heat recovery ventilation. You can read about that in more detail, what these systems are. They are basically there to reduce the or pre-cool the air that is coming from the outdoors. Using heat exchanger, you can assign the efficiency ratios. If again you have specifications of the products that you're going to use, you can try with these efficiency ratios and see how much energy you can save. uh, Fans, again, they can be integrated. You can have a a fan, and you can provide its pressure rise, and you can see how much your ventilation flow has improved. Economizer mode also is something that you can look up in detail and understand what it's about. So essentially the settings tab, the zone settings tab, you can create your own templates. You can use the library that is available. You can modify your library, and this is like again Shubham mentioned that it's a one-time effort. You will have to invest on this, and after once your inputs are finalized, then you can keep tweaking them parametrically to understand the implication of various energy conservation measures. So now the next thing that we will move on to is actually running your simulation model and visualizing the results, how the results appear, what they are actually, and how you load from Climate Studio files into your uh, result viewer. So once all these model inputs are assigned, the next step is to create all them into zones. Right now we had individual zones, and we had window objects, we had shading objects, we had ground surfaces and adiabatic surfaces. Now we have to club them all into a model. Uh, when you bring all of these components together, they will help you form a model. At this stage, you can also assign a particular template from the library if you have created any, or else you can start with the simulation itself. Another interesting component that Climate Studio has is explode your model, which you can find in this tab. It essentially helps you to understand whether your model has been correctly generated. You can check the different surfaces if they are correctly generated, the facade, the partitions, windows, ground floor. So if this is working fine, then that means that your geometry is correct and your surfaces are being read properly. Fairly simple uh, tab that Climate Studio has created, but in the back of it there are a lot of settings, is the Run E Plus, where you can just plug in your model and start with the simulations. It is important to check the location and the weather file. There are some predefined weather files that Climate Studio already has. If your location is in them, that's only in Jaipur, Mumbai, and New Delhi. For other locations, you will have to import your EPW file and plug it into this tab. It's also important that you create a separate directory where all the results get saved. So make a new folder, and for every iteration that you do, even parametrically, rename your model so that your results are saved in different files and you can compare them at a later stage. Before we hit run, because it's very tempting, we see the button and we start clicking on it. Before you hit run, just go and check the settings. So what these settings are, essentially they will give you how your simulation results are being how your simulation is being running and how the results are being outputted. On the first tab, you will see the outputs, the run period, which essentially is that from which time to which time your simulation is running. If you are trying to do some quick analysis only for the summer days or for a particular month, you can change these run periods and you can just simulate your model for the particular period that you're interested in. Uh, Again, the resolution could be hourly or monthly, annual as well, but Climate Studio doesn't have a separate tab for that. The next thing that you can see over here is a very long list of outputs. These are essentially outputs that Energy Plus can generate, or different simulations. You can see uh, you can read about different outputs again on this website, Big Ladder, and Energy Plus input output references. uh, Climate Studio, again, for different kinds of scripts, they have made templates, and in those templates they have already selected the correct outputs that they will require for that particular analysis. So like if you are interested right now in understanding the energy consumption of this model, we are looking at different loads. We are looking at electrical equipment, HVAC load. At the same time, we can turn on some more inputs if we are interested to see the surface heat gains, or we are also interested to see the surface heat storage rate in case we have a thermal mass kind of a envelope. So all of these inputs you have to select if you're using the pre-designed templates of Climate Studio. They have already made these selections, but if you want to add something, you can definitely do that. The simulation time will affect, obviously, if you have too many outputs, unnecessary outputs, especially when you click on the surface outputs, the simulation time will increase a lot. So just be sure that what you are wanting to what do you want to read from the model. If you are interested in thermal comfort, you might need the zone air temperatures as well. You'll need the relative humidity, and you'll also need the operative temperature. So this is something that you can read about and input. The next thing is that in the advanced settings, you will see different kinds of model calculation methods. Primarily, there is a simple zone airflow object and an airflow network model. Both are slightly different. In an airflow network model, the ventilation rates are calculated at each and every step and each and every zone. This is helpful when you are doing a detailed natural ventilation kind of a simulation and testing the effects of your windows placed probably in different orientations. You want to see how the wind flow is generating. So airflow network would be helpful, but right now we are only looking at the simple airflow zone objects. These are also some settings you may want to leave as it is. They are fairly complex to understand, but just don't bother about getting into all of that. And so yes, where your energy plus directory, it probably will automatically find out, but if you are not able to run your model and there are some issues, you can go and check the installation folder also. So for the sake of brevity, I've already simulated the model. When you hit run, the command prompt will open up and the simulation will start, and you will get your results generated as per the complexity of your model. So for this particular model, which had around 16 zones, the simulation took around 2 or 3 minutes, but the simulation time might vary from your model and also from your system. So just 1 second. So I just now want to open up the results directory, how the results directory looks like, and where you can load your results from. So I had given this path before running the simulations. All my output files have been generated. Uh, Climate Studio essentially reads the CSR file, which you can at later stages import into Climate Studio and visualize your results. If you are going for more complex kinds of analysis, you'll also find a CSV file, an Excel file, which you can use to post-process your data and generate different kinds of plots if you are looking at different kinds of data. So now, yes, we have our simulation results. The energy balance is there, and we can visualize in this tab itself. We can see the EUI on different months. We can see the load distribution, heating, cooling. Right now, we are seeing that the lighting load is exceptionally high. That means I think that the lighting power density has to be defined. So when you start looking at these results, don't just believe whatever you are seeing. Try to make sense out of them and try to understand that why a particular load is performing in that fashion. So equipment load should fairly be same throughout the year. So should lighting. uh, the hot water demand is also calculated based on the occupancy, so it should also be fairly same. The cooling load is what we'll be interested in when we are looking at the energy conservation. So we'll try to read where the cooling loads are very high and so on and so forth. We'll also get the EUI The baseline, they have used some AIA standards. That is not what we are referring to. So you might want to check your UIs with the ECBC baseline UIs. Just to give you another example, how do you load your simulation files into Climate Studio? So if you go into the Rhino tab and click on the CS workflow, you will see the play button. If you click on that play button, just a second, you can load your CSR file from wherever you have saved it. So when you are comparing parametrically different design options, let's say you have done 10 different WWR options or 10 different construction options, and you want to compare all of them. Once the simulations are done, you can load them again into the Climate Studio file, and you can see the different kinds of results. So based on the outputs that we had asked for, we'll get different kinds of results. On the building level, we get the energy use intensity. On zone levels, we were also looking at temperature. So we get an hourly plot of 8760 hours of the year, how the zone's temperature are. So we can change the zone which we are looking at. We can select different zones and we can see their results. We can compare the results of different zones, and same way we can select more simulation outputs. If we had, let's say we had energy flows, but we did not simulate them. So these kinds of things can be done fairly easily with Climate Studio. So I hope that a lot of things might be clear now. Now, just in a short 5-10 minutes, Shubham will explain the natural ventilation model. We'll not simulate it and we'll not run it, but we'll just show you how to set up natural ventilation models.
Anmol, so before we hand over to Shubham, I think let's just take few questions up because
Okay.
it's kind of related to what you had explained just now.
Sure. No issue.
Yeah, so first question is, where can we get scripts for reference, as it is difficult to guess which component is to be used and in which flow?
Okay, so that's actually a very good question. Climate Studio has made this component. It's called the workflow template directory. So when you open Climate Studio tab in Grasshopper, this is the first component that appears. When you click select, you will find pre-designed scripts that they have already made for different kinds of simulation models. So you can select whatever you want to simulate. We are currently looking at the energy modeling. For daylighting, you will have to model it from the Rhino tab only, but for energy models, you'll get everything in Grasshopper. So let's say the script that we are right now looking on is the shoebox model script. If you click on it, the script will load. So you will get the script with the components attached. The only thing that you have to understand, and in Grasshopper it's very easy, it's not difficult. You just hover over a component and you will see what that component is about. If you hover over an input, it will also tell you what that input is about. So then you can make sense of what goes in where. Right now they have an internalized geometry. They have already made a small shoebox model. So if you click on run, you will only get that particular model simulated. But when you are trying to input, so this is the model that they have already inputted. So you need to disconnect all of these tabs, and then you have to connect your own geometry the way we have explained into this particular tab. Where your zones, windows, boundary conditions, and shading objects go, and then you can select your location and start simulating. So I hope that answers the question. You can find different kinds of scripts for energy modeling.
Okay, thank you, Anmol. We'll take the next question. It's how to assign internal air walls.
Okay. So when I was explaining this concept, I think I have answered one question on the chat. A person had asked that where do you actually put internal air walls? So as I was mentioning that in our model we have a open plan which has the kitchen and dining room and the living room all in one open area. In terms of thermal loads, they will be very different because my kitchen will have a different kind of occupancy, will have a different load as compared to my living room, and their exposures are also different. This is facing south, this is facing north, so I have to create different zones. Now when I create different zones, I will have these boundaries between these zones that will be read as some kind of an object. If I don't assign it a property, it will get assigned to this the template, whatever you have given the zone template. So if it is a brick wall, then this partition will get assigned as a brick wall. But to be able to avoid that, we have to, before running any simulation, before doing anything, we'll have to extract these surfaces. You can extract these surfaces from Rhino itself. Just I'll give you an example. If this is the bref, this is the box that you have, you can write extract surface and you can click on the particular surface and you can extract it and bring it into Grasshopper, so that later on you can use that particular surface in any fashion. So now when I have this internal air, I mean this surface extracted, I've actually assigned it as an open partition. uh, I've assigned it as a window first. That's probably not the best way to do it. If you are making your model surface by surface, you will have to straight away input it as a air wall. But again, a proxy to that is that I've modeled it as a window, but the material I've assigned it, it's an air wall. So I'll have a frame around this zone because it's not 100% glazed. I have given this as an 80% opening, but I have given the material as an air wall. So this is a proxy, and uh, when you are modeling at that point, you can model surface by surface and group all your surfaces into a zone. Because I was modeling from volumes, I had to take this method. So I hope that answers the question.
Okay, yeah, thanks, Anmol. So we'll take two more questions, which is from Garima Agarwal. How do I check comfort hours? That's her first question. And the next question is, how do you elaborate on the advanced settings in running Energy Plus, especially the airflow model?
Okay, so the first question is, how do you compute comfort hours? For that, see, in order to compute comfort hours, you will need air temperature, relative humidity, and operative temperature as an output. Climate Studio already has made certain workflows for spatial thermal comfort, but they are based on ASHRAE standards. So you might want to check them if that interests you. But I don't think we are following ASHRAE standards. Or if you are following, then you can do that. But when you have your air temperatures, operative temperatures, and relative humidity from each and every zone, then that requires a post processing. You will have to take those hourly values into maybe Excel and then compare it with your IMAC band, compare it with your thermal comfort threshold. So then you will be able to get your comfort hours. It's not a very straightforward process, but still, for the sake of simplicity, you can compare your operative temperatures with your monthly thermal comfort band. If you're looking at, let's say, Chennai, in June, July, the thermal comfort band lies between 26 to 34 degrees Celsius. If my operative temperatures are falling between that, then I can say that my zone will be thermally comfortable. Uh, you can check out this script. I'm not very sure about it using in Solar Decathlon because it's fairly complex. So, but still, you can look at Solema's website for the tutorial on spatial thermal comfort. But uh, for thermal comfort, as per Indian standard, as per IMAC, you have to do some post processing to the outputs that you obtain from the simulation model. So I hope that the first question gets answered over there. The second question, I actually couldn't understand. You want to ask that how do you expand the advanced settings, or what these advanced settings are about? Could you please elaborate on that, Amanda? Is that possible? If
Yeah,
whoever
so
has asked the
so
question.
I request Garima to kind of elaborate her question and then put it up. Will take it after Shubham kind of takes over natural ventilation.
Yeah,
Over.
Amanda,
Yeah.
I want to ask Anmol to clarify one thing. So, Anmol, when you had gone to your EUI results, there
Mm-hmm.
were 3 or 4 EUI numbers that you were showing, right?
Yes.
Yeah. So, the top one on that is the site EUI, which is the EUI that has come out of the model.
Mm-hmm.
And as far as we are concerned here, that is the number that matters, because
Yes.
that's what you have modeled. Those are the results of your model. So I just wanted to clarify that for the participants.
Yeah.
Yeah, thanks.
Yes. So this is actually our EUI that model is getting.
Okay. Thank you, Anmol. Over to you, Shubham. Yes.
Yeah. Yeah. So is the screen visible?
Yes, Shubham. Yeah.
Okay. Just a second. So yeah, once everything is once you have simulated your model, once you will observe that all this part, the blue portion which is defining, it's the cooling, and basically since we are simulating for chilling, we don't have anything for heating. So and we all know that the best cooling strategy is the passive strategy, is the natural ventilation, because it's free of cost. We don't have to spend in anything. It's just the design, it's the design process which we have to follow, and to the way windows are designed. So basically no operational cost. So from this directory which Anmol told you about, the template, you can go into the select, you can select this energy model, and then you can click on the natural ventilation. Once you click on the natural ventilation, you will get get this script as your for your model. Since you have already made the model for all the zones and everything, so that same thing, the same model which you designed for the here. Just a second. I will turn off the layers so that it's easy for you to understand. So yeah, this defined model which you made here, the same model will be put into the simulation tab for the natural ventilation, where everything is being defined here. So the good thing which this climate studio gives you, they gives the control for for making the schedules, and these schedules can be derived from the from our parameters. The parameters can be anything related to the outdoor RH or temperature or visible or anything which you are which you wanted to define at. So since here the pre-installed script tells you about the DBT, the weather, and it derives the uh, schedule based on the DBT, and here the DBT controls, we have already defined the controls which are dependent on this 28 degrees Celsius and 26 degrees Celsius. So here the whole concept is, whenever the temperature is between 18 and 26, we will use the natural ventilation irrespective of the RH. So so using that, the black portion, and so this whole template divides into the yes or no, and this whole schedule defines you whether in which all climates or at which all temperature you can switch on your natural ventilation. So the black defines that you can't use it in that area, and the white defines that you can use in that. So once this heat map can be converted into a library, so you don't have to do it anything. It's just a visualization heat map, and this heat map is converted into a library. ultimately you can use it for all kind of strategies. You can use it for the heating, you can use it for the cooling and the mechanical ventilation as well. So once this all these four different strategies are being defined, and uh, these schedules will automatically be switched to this library. This library ultimately needs to be fit in your ultimate zone which you made at the start. So here for the bedroom, if you are designing for the bedroom for any other space, you have to define in the HVAC tab. So initially what when we designed it, we put the schedule as all on, which means 24/7, whatever the temperature is, the system will be switched on. If you will observe, we use the name. Just a second. We define the schedule as the heat available, cool available for in this case particularly. Just a second, the computer is bit. Yeah. So here we define the schedule name as the natural ventilation available, heating available. So these names will be shown automatically when you will use here the settings in the same tab. So if you go to the HVAC tab, you will switch on the availability schedule, and you will see that the schedule which you derive are here. These are the same thing, and you don't have to put the numbers in this case. So since we are putting it for the heating, I will use the heat available option in this case, cool available option for the cooling, and the natural ventilation option for the natural ventilation available. Once this thing is done, you have to rerun the simulation. Oh, since we did not turned off the simulation tab, so it is automatically simulating. So ultimately you will find out that the final result is the reduction in the energy, and ultimately so yeah, we are safe now right now. So the simulation did not run. So here when you will turn this true, and you will again see the reduction in the energy, and that is definitely because of because of the usage of the free cooling. So yeah, then this so ultimately using this tab for your scheduling is bit easy, because you don't have to use any other you don't have to manually put it automatically make the schedule for you. Yeah, over to Anmol.
Okay.
So I think that we have covered most of what was on our agenda. I know that the software is fairly complex and energy modeling in itself is a new concept. So there will be a lot of questions, but for the sake of the time, we might not be able to explain any further, but we'll be happy to take up questions, and as many questions we'll be able to address, I think we'll focus on that.
Okay, so in that case, let's take up Garima's question again. So she would like to know how the airflow model runs and the settings related to with it.
Okay, so I think that you are trying to understand, Garima, how the different energy plus models run. What are the parameters behind them? So in the advanced settings, again, when you before simulating, you will find this settings below this icon. So you can hover over to the setting.
Anmol, your screen is not visible.
Yeah.
Just a second, sorry. I think there's some problem. So sorry for the issue. My internet is a bit slow, so it gets freezed. Is it visible now?
Yeah.
Yes, Anna. Yeah.
Okay. So when you click on these settings, you will see the energy plus settings for simple zone airflow objects and airflow network. Airflow network, if you want to understand what airflow network is, I'll just pull up the basic directory tab. From the directory tab, I'll just quickly explain what airflow network model is. So the basic difference between a zone ventilation and an airflow network is that the ventilation is now calculated more accurately, as you would have done in a CFD model. You will have different pressure and wind velocity coefficients at each and every boundary of your zone. So airflow network also calculates these at different intervals, not as refined as a CFD simulation, but it is fairly more accurate as compared to the regular ventilation method. What airflow network will do, it will create some flow paths so you can understand how the ventilation is happening. It will just take a few seconds before the simulation happens. Just a second. So you can actually visualize the vectors of wind, how at different time steps, this is actually the time step. So you can visualize the wind direction at different time steps, and it is being calculated in real time. So for natural ventilation, airflow network model is slightly more accurate, and you might want to read more about it on the Energy Plus Engineering reference document. You will find the physics behind it. So you can see that the vectors have changed. Basically, the ventilation velocity has reduced. Also, the directions have changed. So all of this is being calculated as your simulation time proceeds. So all of this is being calculated in an airflow network model. And when we do a simple natural ventilation model, we always assume a constant flow rate. We'll have to input that flow rate, but in reality, that will not happen. When your outdoor air speeds drop, your flow rate will change. So that is the thing that you can visualize in the airflow network model, that with the change in your air velocity from different zones, your air changes per hour or your flow rate will also vary. So this is a fairly realistic approximation when you're doing natural ventilation simulation. So I hope that answers Garima's question.
Yeah, thank you, Anmol. So we have a similar question from two attendees. So the question is, how can we define WWR to a specific wall?
Okay, so basically this is again a geometry modeling gimmick. So if you are very well aware of Rhino and Grasshopper, you can figure your own way out to assign a glazing ratio, a WWR. What I have done initially, I had explained you that I had extracted different window surfaces, basically the faces on which the windows will come. I had previously extracted all of them separately depending upon the orientation, and then I use this component which is available in the Climate Studio tab. When you open a shoebox model, you will see this particular tab. If you double click on it, you will see the script behind it. What it does is basically it will scale down that surface by a particular percentage. So you can input your WWR as a percentage of the wall area. If you want it to be 40%, then this component will scale down your surface to 40%, and this will be your the glazing, final glazing that you will get on the model. So you can use the shoebox modeling workflow that is there in Climate Studio, and it has already a component to assign WWR. So I think that same approach can be followed.
Okay, thank you, Anmol and Shubham. So with that, we actually have answered all the questions. Would you like to kind of, add any kind of tips or, comments before we end the webinar?
So I am actually surprised that the questions have ended, because I thought that there'll be more.
Okay, actually, we have one more coming up. So
Okay.
let's take this one. How do we define the shading devices?
Okay. So in again, this will be a geometrical gimmick that you'll have to do. If you have these windows surfaces out, uh, just a second. So you can use these surfaces to
You,
model.
Anmol, so you haven't shared your screen yet?
Sorry.
Yes, we can see you.
So again, shading devices are something that is a part of geometry. It's not there in Climate Studio. They have made some components in 1 or 2 scripts. You can use those components, or you can figure your own way out of modeling shading devices. Uh, Essentially, what I think the person who has asked this question would be interested in to model shading devices dynamically. With the changing WWR, the shading device also changes, and you are able to control it. So you'll have to go into Grasshopper. You'll have to uh, explode this surface, uh, and you'll have to pick up the line on which the shading device will be constructed. So if this is the surfaces of your windows, you'll have to pick out the edges, and from those edges you can extrude those edges to make your shading devices. That is one option. I think the same workflow is also adopted in one of the scripts. The If you go into the directory of Climate Studio, there is a script for Solar Decathlon India. In that script, the same kind of a workflow is made, so you can use that particular component itself, and you can model the shading devices. I think this is the workflow. So if you open this workflow, you will find a tab where the shading devices are made. Just uh, pull out that particular part from the script and attach it with your window. I think that should work.
Okay, thank you, Anmol. So there's one more question. I am not sure if you would be able to explain it right now. So the question is, can you explain how to post-process the temperature data for IMAC model?
So sorry, I won't be able to answer this question right now. It will take time. But I think that just to give you an idea, for IMAC, you will have different spreadsheets for different cities where the upper and the lower band of the comfort ranges is given for different types like natural ventilation, mixed mode, or air conditioned. You can use those spreadsheets and bring your operative temperatures data into that spreadsheets, and then it's Excel. So I'm not here to explain Excel. So you can use Excel to compare both of these values. You will get your answer.
Yeah, and in the next part of the webinar where design builder is going to be talked about, Arjun is planning to just do a quick review of how to do that. I don't know how much detail he'll go into, but if you attend that webinar, you'll be able to see at least the approach to doing it.
Okay. Yeah, so thank you, Prasad. Thank you, Anmol and Shubham, for such a wonderful walkthrough to the software as well as, its application for designing a net zero energy buildings. I hope the students have now gained energy and enthusiasm that they are ready to take up the challenges.